Inference for relationships, the chi-square test.
A test for association. When looking at useful terms regarding the chi-squared test, you need to first understand the conditions in which must be met to perform the test. The first one being random. The data needs to come from an experiment that is randomized just to provide a good basis for the entire test itself. The next one is independent. If there is no replacement being used in the test, the population needs to be at least 10 times as large as the sample. This just makes sure there isn't any correlation between the two things being tested. The next is a large sample size. This is extremely important because this is regarding the expected counts. And the expected counts need to be at least 5 after the math has been done. The next term to note is expected count itself. When trying to find out the expected counts, you need to go to the rows and columns of the table that's given and use this following equation to figure out for each variable what the expected count should be. It's row total times column total over table total. And finally, we need to know about the null and alternative hypothesis. The null is stating that there is no association between the two variables, that they're completely independent from each other. The alternative is that there is an association, and that's what we're trying to see with the whole test, if it's true.
The chi-squared distributions are a family of distributions that take only positive values and are skewed to the right. A particular chi-squared distribution is specified by giving its degrees of freedom. The chi-squared goodness of fit test uses chi-squared distribution with degrees of freedom equaling the number of categories minus 1. The figure shows the density curve for 3 numbers of the chi-squared family of distributions. As the degrees of freedom increase, the density curves become less skewed and our larger values are more probable.
So the question is, does background music influence what customers buy? In the problem, the observed counts are given, and we need to find the expected counts. To do so, you do row total times column total over total total. So shown here is the expected counts, and now you have the observed and expected counts, so you can get your chi-squared number. And here's the formula. It's the sum of observed minus expected squared over expected. And the final answer is 18.28. And now we can start the significance test. We start off with the HO, which is there's no difference in the true distributions of entrees ordered when various music or no music is played. And the HA, the alternative hypothesis, is there's a difference in the true distributions of entrees ordered when various music or no music is played. So now that we have the observed and expected counts in graphs, we can enter it in under matrix, and we need to edit them, and each of them need to be 3 by 3. You can enter in the data underneath for both of them. And with that, you had a stat, test, chi-squared test, and then calculate, and here it gives you your chi-squared number and your p-value. After getting a p-value of 0.0011 from the calculator, we can now interpret the p-value and say that the p-value, with the p-value less than alpha, we reject HO, and there's a convincing evidence of a difference in the true distributions of entrees ordered at this restaurant when various music or no music is played.